Hi everyone, my name is Ravi and welcome to the fourth class of permutations and combinations. Okay, now let's move to question number 4. We are continuing from last video only. Okay, we were discussing combinations, right? Question number 4. See, so combinations and factorial we are discussing. We discussed factorials, we discussed combinations, right? Now we're doing questions here. Question 4. Very important questions we are doing here. Okay, see, 10 students are to be ranked from 1 to 10. Okay, in how many ways they can be ranked? In how many ways they can be ranked? They can be ranked such that now learn many parts here. First, such that first part. We'll make it A. A is always ranked above B. Okay, A is always ranked above B. Second part, A is ranked above B. B is ranked above C. Third part, A is ranked above B. B is ranked above C. And C is ranked above D. Okay, so 3 questions we'll do, right? 10 students are to be ranked from 1 to 10. In how many ways they can be ranked such that A is greater than B? That means A is always ranked above B. So let's say A and B are the 2 students among those 10 people, right? So in how many ways they can be ranked such that A is greater than B, right? So first A part we'll do, and we'll do it again 2 methods, right? Both the methods, concept of both the methods are very important. Answer will be obviously same, right? But the concepts are very, very important, right? See, the first method basically is, if 10 students are to be ranked from 1 to 10, it can be directly ranked as in how many ways? So 10 students to be ranked from 1 to 10. So it's like shuffling of 10 students from 1 to 10. So they can be ranked in how many ways? 10 factorial, directly 10 factorial, right? Why? Because if there are 10 places, 1 to 10, so in first place, A to J can be ranked in 10 ways, right? In second place, already 1 is ranked. So now 9 people are left. They can be ranked in 9 ways. Now, right? I can also discuss this in terms of ranked part, right? Ranked part. Okay. What I'm trying to say is, let's say rank 1, rank 2, rank 3, rank 4, rank 5, rank 6, rank 7, rank 8, 9, 10. Rank 1 can be given from 8 to 10 people. Rank 2 can be given from, already 1 people have given rank 1, right? So 9 are left. So 9 people. Rank 3 can be given to 8 people. Rank 4 can be given to 7 people. Like this to 10 into 1, right? What is the answer? Answer is 10 factorial. So 10 people can be ranked from 1 to 10 in 10 factorial ways, right? Now, in how many cases A will be greater than B? That means A is ranked above B, right? So very important point. A is ranked above B. See, if I'm ranking all these people, right? See, there are 10 places. If I'm ranking all these people, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So suppose A is at rank 1, okay, and B is at rank, let's say this rank 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now see, understand this point very carefully here. If A is rank 1, and let's say B is at rank 4, we'll count this case, right? Obviously, and then others are ranked randomly, right? So I'm concerned with only A and B now. So this is one of the case, right? When A is at rank 1 and when B is at rank 4. Another, its converse case will be there when B is at rank 1 and when A is at rank 4, right? But this case I have to take, this case I don't have to take, because B is ranked in second case, B is ranked above A. Now another case I can take, let's say A is at rank 2 and B is at rank 7, right? It's another converse case will be there when B is at rank 2 and A will be at rank 7, right? And rest 8 are arranged in random order. So again, I can't take this case I can take. So that means A will be always ranked above D. So what I'm trying to say here is, if out of every case in 10 factorial cases, we have to see only arrangements of A and B. So at every 2 places, one A will be at first, B will be at second, and another time B will be at the same first and A will be at the same second. So those 2 cases I have to take only one case, because in the second case B is at previous greater rank than A, right? So B is placed at greater rank than A. I don't have to take that rank. They don't have to take that case, right? Suppose A is at rank 2, B is at rank 5. And it's converse cases. Suppose A is at rank 2 and B is at rank 5. So its converse case is what? B is at rank 2 and A is at rank 5. So A2, B5 I can take, but B2, A5 I can't take because A has to be ranked above B. So out of every 2 case, I am taking only 1 case. So out of total 10 factorial case, how many cases I want? I want 10 factorial by 2. So answer for this question is 10 factorial by 2. A very good concept, super concept, right? Answer for this question is what? 10 factorial by 2. This is the answer for this question. 10 factorial by 2. Correct? Right. I hope it is clear. So for every 2 case, I am counting for only 1 case, right? This is the first method to do it. First method, right? Now we'll discuss the second method as well. We'll discuss second method as well, right? So in second method, what I'll use is use the funda of combination, right? I'll use the funda of combination in the second method, right? Answer, we have to solve it. What is the answer? Answer is for sure 10 factorial by 2. For first question, 10 factorial by 2. Now for method 2, again a very good concept, but answer will be same obviously. What is the concept here? See, again there are 10 people, right? So there are 10 ranks here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ranks here. For A and B, since there are 2 people, I can choose any 2 ranks. Those 2 ranks can be chosen in 10C2 ways. So those 2 ranks can be chosen in 10C2 ways. 10C2 ways, right? Now, what does this 10C2 mean? This is so important, this thing, right? What does this 10C2 means? 10C2 means out of 10 things, I can make 10C2 different groups of 2 things, right? So what is the value of 10C2 here? So value of 10C2 is how much here? Simply calculate 10 into 9 by 2 into 1. That is 45. From 10, go 2 steps back, divide by 2 factorial. That is 45. That means I can make 45 groups of 2 things, right? So there are 10 things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how many? What does this 45 means? This 45 means there are such 45 groups like 1 and 2 rank, 1 and 3 rank, 3 and 4 rank, 8 and 6 rank, 5 and 9 rank, right? There's so many orders here, right? Those orders. 1 again, or 1 and 2 and 2 and 1 will be counted as only 1. Will be counted as only 1, right? We have discussed this thing. In combination, order is not important. How many different groups I can form? That's it, right? In those groups, order is not important. So I can form 45 different groups, right? And when we write 10C2, you be absolutely sure that every pair has been counted, right? Every group of 2 has been taken. Okay, that is the meaning of 10C2. So now, if you take the rank 1, 2, you need to place A and B here, right? You need to place A and B. So obviously, you'll place A at 1 and you'll place B at 2 because A has to be above 2. If you pick rank A and 3, you'll place A at 1 and B at 3 because A has to be above B. If you pick ranks 8 and 6 as one pair in 10C2, one group is of 8 and 6 also. So A will be at 6, B will be at 8 because A has to be ranked above B. If you take 5 and 9, so A has to be 5, B has to be 9, right? That basically means that out of 10 different ranks, I can select any 2 ranks in 10C2 ways. So I can form 10C2 different groups of 2 ranks. On every group of 2 rank, I can place A and B in only one way. On every group of 2 ranks, I can place A and B in only one way because if I select rank 5 and 9, A has to be 5, B has to be 9. If I select rank 8 and 4, A has to be 4, B has to be 8, right? So on every group, I can give or I can assign ranks to A and B in only one way. And now rest 8 people, right? Because there are 10 people to be ranked. There are 10 students to be ranked, right? So every one, the other 8 people can be randomly arranged in 8 people, 8 places. The shuffling of n different things at n places is how much? N factorial. The shuffling of 8 different people or 8 students at 8 different places is how much? 8 factorial, right? That is 8 factorial. Once you solve it, you will get 10 into, what is 10C2? 10 into 9 by 2 into 1, right? Into 8 factorial. This is nothing but 10 into 9 into 8 factorial is what? It is 10 factorial by 2. This is the answer we got, right? This is the answer we got in the previous method also. So answer is same, 10 factorial by 2, but this method is different. And this is a very good concept. Combinations, right? A very good application of combinations concept, right? In combination concept, what happens? you have to select only groups. You don't have to bother about their shuffling and all, right? So out of 10 different numbers or 10 different ranks, I can select any two ranks in 10C2 ways. That means, what is 10C2? 45. I can make 45 groups of 2 rank, like 1 and 2, 1 and 3, 3 and 4, 8 and 6, 5 and 9. Like this, I can make 45 different groups. On each group, I can assign rank to A and B in only one way, because A has to be the greater rank and B has to be the lesser rank. So 10C2 into 1. And the other 8 things can be, or the other 8 students can be assigned at those 8 random ranks in 8 factorial ways, right? So both the methods are very important, right? Now let's move to question number 2. Now just try it, right? You try in your mind what is this question, answer for question number 2 here. That is, A is greater than B is greater than C. What is the answer? I think you got this answer in mind, right? Answer would be 10 factorial by 6. Answer will be 10 factorial by 6. Why 10 factorial by 6? Can you tell me? Can anyone tell me why 10 factorial by 6? It is because, see, I'm solving it. Again, 10 students can be ranked in 10 factorial ways, right? Now again, out of those ranks, right, if the ranks are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, right? Suppose A is here, A is at rank 1, B is at some rank 4, okay, and suppose C is at rank 9. Okay, so A, B, or C are 1, 4 and 9. So if A, B, C are at 1, 4 and 9, okay, so this can be shuffled, okay. Now let me show you. This can be shuffled in how many ways? So A, B, C are, let's say, 1, 4 and 9. So rank 1, 4 and 9. Rank 1, 4 and 9. So in how many ways ABC can be shuffled? A, B, C, B, A, C, C, B, A, then C, A, B, like that, right? How many ways? So at 1, 4 and 9, A, B, C can be shuffled in how many ways? 3 factorial, that is 6 ways. So if you take any group of 3 rank, let's say 1, 4 and 9, A, B, C, in this total 10 factorial, there are 6 ways of 6 ways counted. 6 ways counted, right? But we have to take how many ways? We have to, out of those 6 ways, I have to take only one way, that is 1, 4 and 9. That is, A has to be before B and B has to be before C, right? So any group of, right, in out of 10 factorial, all the possible ways are counted. So if you see only for A, B and C, right, then for if A is at rank 3, B is at rank 5, and let's say C is at rank 10. So at 3, 5 and 10, they can be shuffled in 6 ways, right? A3, B5, C10, then A5, B3, C10, then C5, A3, B10, right? Like this I can shuffle in 6 ways, 3 factorial 6 ways, right? But out of the 6 ways, I want only one way. That is, A should be greater than B, should be greater than C. That means A should be at 3, B should be at 5, and C should be at 10. So out of every 6 ways, I want only one way. So what is the answer? Answer will be how much? 10 factorial divided by 6. Why this 6? Because 10 factorial divided by 3 factorial. Okay, right. I hope it is clear, right? Method 2 is also same thing. Okay, we can discuss method 2 also. Method 2 is also same thing here. Out of 10 different ranks, I can select any 3 ranks for A, B, C in 10C3 ways, right? So out of 10 ranks, I can select any 3 ranks for A, B, C, D in 10C3 ways, right? So I can form 10C3. What does 10C3 means? I can form 10C3 different groups of all the rank, like 1, 2, 3 in any order will be counted as 1. 3, 4, 5 in any order is 1, right? 8, 9 and 6 in any order is 1. 2, 5 and 7 in any order is 1, right? And how we can place A, B and C? So A will be always at 1, B will be always at 2, C will be always at 3. Or here A will be always at 3, B will be at 4, C will be at 5. Because what we want A to be greater than B to be greater than C, right? 8, 9, 6. A will be at 6, B will be at 8, C will be at 9. So that means out of 10 different ranks, I can select any 3 ranks in 10C3 ways. So I can form 10 C3 different groups of, I can form 10 C3 different groups of 3 ranks, right? 10 C3 different. What is 10 C3? 10 into 9 into 8 by 3 into 2 into 1. That is 120. So I can, out of 10 different ranks, I can form 120 different groups of 3 ranks. Sorry. So I can form 10 C3 different groups of 3 ranks, right? Out of this 10 C3 different groups, okay, how many groups are out of this 10 C3 different groups, okay, in how many ways I can place A and B? So I can place A, B and C in only one way, because on every group they can be placed in only one way, they can't be shuffled, and rest other can be done in 7 factorial ways, right? Rest 7 people can be given, say, 7 random ranks in 7 factorial ways, right? What is the answer? So answer for this question is what? Again, if you solve it, you'll get 10 factorial by 6. 10 factorial by 6 is the answer, right? Okay. Now, third question was there. Same thing. A has to be greater than B. B has to be greater than C. C has to be greater than D. Same thing here. 10 people can be given ranked in 10 factorial ways, right? In that, A has to be above B. B has to be above C. C has to be above D, right? That means if you take one case of A, B, C and D, if you case one case of A, B, C and D in any 4 ranks, right, they can be shuffled in 4 factorial, that is 24 ways. So if you take any one group of 4 ranks for A, B, C and D, on those 4 ranks only, they can be shuffled in 24 ways, that is 4 factorial, right? But out of every 24 ways, out of that 24 ways, I want only one way, where A is greater than B, B is greater than C, and C is greater than D, right? So out of those 24 ways, I want only one way, right? So every group of 4 rank, if I shuffle A, B, C, D, on every group of 4 rank, they can be shuffled in 24 ways. But out of every 24 ways, I want only one way, right? So out of 10 factorial, out of every 24, I want 1. So out of 10 factorial, how much I want? 10 factorial by 24. That is 10 factorial by 4 factorial. This is the answer for this question, right? A very nice question. It is very nice question. Very conceptual question. Okay, should be able to do it now. Okay, I hope it is clear, right? Now next question we'll do. Next question. Okay, so let's move to question number 5 now. Question 5. Okay, how many 3-digit numbers, how many 3-digit numbers can be formed with digits 1 to 9 such that hundreds place is greater than tens place is greater than ones place. Okay, hundreds place is greater than tens place is greater than ones place. How many 3-digit numbers can be formed, right? Now see here. So this is 3-digit number, units place, that is ones place, tens place, okay, units place, that is ones place, tens place, hundreds place, right? So hundreds place should be greater than tens, tens should be greater than units or ones, right? So see, directly I can do, there are 1 to 9 numbers available here. So from 9 numbers available, I have to select any 3 numbers, right? So from 9 numbers available, I can select any 3 numbers in 9 C3 ways. I can select any 3 numbers in 9 C3 ways, right? So in 9 C3 ways, I can select any 3 numbers. Now what does 9 C3 means? Again, 9 C3 means, what is the value of 9 C3 first? So value of 9 C3 is 9 into 8 into 7 divided by 3 into 2 into 1. So that is 84. Okay, so 9 C3 is what? 9 C3 is 84, right? That means we can make 84 such groups, right? I can make 84 such groups. Like out of 9 numbers available, I can make 84 groups of 3 numbers each. That means like 1, 2, 3 or 3, 5, 6 or 6, 8, 9 or 8, 9, 6 in any order, right? In any order, 8, 9, 1, 5, 9, 3, like this I can make 84 different groups, right? Now in any order, one group in any order, right? I'm sure that by now you understood this part, that in NCR, when you are making groups, order is not important, right? So 1, 2, 3 in any order is counted as one group. So how you place this 1, 2, 3 here? So you place this 1, 2, 3 as like 3 is greater than 2 is greater than 1. Right? How you place this 3, 5, 6 here? So like 6 here, 5 here, 3 here. How will you place this 6, 8, 9 here? So like 9 here, right? 9 at hundreds place, 8 at tens place, 6 at unit place, right? That means I can form 84 groups here, and all the groups can be placed in only one way. So I can make 9 C3 groups, that is 84 groups, and all the groups can be placed here in only one way. No shuffling, because shuffling means if I shuffle any group, if I shuffle 1, 2, 3, so 1 will come here, 2 will come here. That will, in that case, hundreds place is not greater than tens, is not greater than ones, right? Therefore, what is the answer? So I can make 9 C3 different groups, and each group can be arranged in only one way, or each group can be placed in only one way, right? What is the answer? Answer is 84. So 84 is the answer for this question, right? Okay. Now question 6. Question 6. See, there's a flag here. A flag is here having 4 strips, 4 vertical strips, right? Flag is having 4 vertical strips or stripes. Okay. Now it can be painted. It can be painted. It can be painted with 7 colors. That is Vibgyor. Vibgyor, 7 colors like Vibgyor. Okay. So in how many ways it can be painted, right? The question is, in how many ways it can be painted? In how many ways it can be painted such that, first question, in how many ways it can be painted such that all 4 colors are different, right? So in how many ways the flag can be painted, right? So we have like 7 colors here. Option is Vibgyor, 7 colors here. So in how many ways it can be painted such that all 4 colors on these stripes are different, right? So if all these 4 colors are different, that means out of the 7 colors, I can make how many groups of 4 colors? I can make 7 C4 of groups of each color, each 4 color, right? For every 4 colors, I can make that 7 C4 group. Like suppose one group will be violet, indigo, green and yellow, let's say, right? This is one of the groups of 7 C4 groups, right? Now this group, now flag will be changed, right? If I shuffle it, if I bring yellow this side, if I bring violet this side, or if I shuffle indigo and green, the flag will be changed, right? So here shuffling can be done. Okay, so the shuffling of 4 colors can be done in how many ways? 4 factorial ways, right? There are 4 colors, so shuffling of 4 colors can be done in 4 factorial ways, right? So what is the answer? 7C4 into 4 factorial, that is 35 into 24. You can solve it, you'll get the answer as 840. So 840 is the answer for first question. All 4 colors are, in how many ways can flag can be painted? Using 7 colors when all 4 colors are different. 7C4 into 4 factorial, right? Now B question, this B second part, B, when two of the colors are violet and blue. Okay, so 2 of the colors are violet and blue. In that case, what is the answer? So when 2 of the colors are violet and blue, right? So you see, in how many it can be colored? So that means 2 colors, violet and blue, are already here. Okay, so violet and blue are already here. Fine, no issue. So we'll place violet and blue. So let's say violet and blue are already here, right? That means I from the 7 colors I can't pick violet and blue. So I can pick, I have the 5 options: indigo, green, yellow, orange and red, right? So out of these 5 colors I can pick any two. So out of these 5 colors I can pick any two in 5C2 ways, right? So I can make any two in 5C2 ways, right? That means I can make groups of 2 color in 5C2 ways. What is 5C2? 5C2 is nothing but 10 ways, right? In 10 ways. And now suppose those two colors are, let's for example, those two colors are yellow and red, right? So now all these again, all these 4 colors can be shuffled, right? So all these 4 colors can be shuffled, or their positions can be changed in how many ways? 4 factorial ways, right? So 5C2 into 4 factorial. What is the answer? 10 into 24, that is 240 is the answer. So answer for this question is 240, right? So in how many ways flag it can be painted when 2 of the colors are violet and blue, right? So violet and blue are the 2 fixed colors now, right? So from the other 5, other 5 colors, I can pick any 2 colors in 5C2 ways, obviously, right? And just 5C2 into 4 factorial. This gets shuffled in 4 factorial. Right? Third one, that is C. No two colors are adjacent. Okay, so no 2 colors are adjacent, right? So when no two not sorry, I'm language mistake, right? No two same colors, I should write here. No two same colors are adjacent, right? So in this case, no two same colors are adjacent. That means, you see here, that basically means that in the first place I can have all these 7 colors. The first place can be painted, this first stripe can be painted in all the 7 ways, right? That is 7 colors. Okay, the second stripe can be painted in 6 colors, because one color I already, suppose I've used yellow here, so I can't use yellow here now. I can't use yellow, right? So only 6 options are left, because no 2 colors are adjacent, right? In third place, now suppose I have used green here, right? So for this third place I can't use green, but here I can use yellow. That is the color of first stripe, right? Because simply condition is no 2 colors are adjacent, right? So again, in the third stripe we had all the 7 options, but out of that I can't use green because green is adjacent color. So again 6. Okay, and in the fourth place, again suppose I have yellow here, so again that yellow I can't use here, right? Rest all I can use. So again 6 options. So it's like what? 7 into 6 cube. So 7 into 6 cube is the answer. That is 216 into 7. That is 1512. So answer for this question is 1512. Right. This is question number 6. So a good concept to have. Right. This kind of questions will help you in solving the tougher questions. Right. Okay.